Hello students, welcome back to the science class. In the previous session we have completed unit 1 heat and temperature lesson. In this class we are going to see about unit 2 electricity. Electricity. We have a lot of electronic things in our home. These pictures are home appliances. Blender, juicer, coffee grinder, coffee maker, etc. Many countries began using electricity for domestic purposes. 17 years after the New York in 1899 electricity first came to India, the Calcutta Electric Supply Corporation Limited commissioned the first thermal power plant in India on 17 April 1899. So we can use a lot of electronic things in our home. Sandwich maker, hand mixer, standing mixer, washing machine, refrigerator, dishwasher, gas range and oven. These things are make very easier and quick we can do the work. Thomas Alva Edison, he found electricity. In 1882, when it was sunset in the west, that miracle happened in New York City. When Thomas Alva Edison gently pushed the switch on, 14,000 bulbs in 9,000 houses suddenly got light up. It was the greatest invention to mankind. From then, the world was under the light even in the night. So the scientist Thomas Alva Edison found the electricity. Atoms. You know about atoms very well. In the earlier classes, we have seen briefly about atoms. We have learned that all materials are made up of small particles called atoms. The center of the atom is called the nucleus. The nucleus consists of protons and neutrons. Protons are positively charged and neutrons have no charge, so neutral. Negatively charged electrons revolve around the nucleus in circular orbits. So electricity is a form of energy. Already you know that heat is a form of energy, and also electricity is a form of energy that is associated with electric charges that exist inside the atom. So electric charge is measured in a unit called coulomb. 1 unit of coulomb is charge of approximately 6.242 into 10 power 18 protons or electrons. Electric charge. Electric charge is measured in a unit called coulomb. 1 unit of coulomb is charge of approximately 6.242 into 10 power 18 protons or electrons. Electrical charges are generally denoted by the letter Q. So, charge is responsible for electrical forces. Charge must be conserved. It cannot be created or destroyed. Charge is measured in coulombs C and is abbreviated Q. The charge of one electron is minus 1.602 into 10 power minus 19 coulomb. Minus 1 coulomb equals the charge of 6.24 into 10 power 18 electrons. Next, electric current. The flow of electric charges constitute an electric current. For an electrical appliances to work, electric current must flow through it. An electric current is measured by the amount of electric charge moving per unit time at any point in the circuit. The conventional symbol for current is capital I. So electric So electric current is flow of electrons. Cross section area, the yellow dots are electric charges. So what is electric current? Direction of flow of current is called electric current. So the flow of electric charges constitute an electric current. For an electrical appliances to work, electric current must be flow through it. Next, unit of electric current. Length can measure the unit of meter, and mass, the unit of mass is kilogram, and unit of time is second. Already you know that. And the electric charge can measure using the unit of coulomb, and also electric current can measure and unit have unit. The SI unit for measuring an electric current is the ampere, which is the flow of electric charge across a surface at the rate of 1 coulomb per second. The formula capital I equal to Q by T. So electric current is the rate of flow of charge. Current equal to charge by time. Current is denoted as capital I and charge denoted as Q and time is denoted as T. So unit of current equal to ampere equal to 1 coulomb by 1 second. Here I is current in ampere A and Q charge in coulomb C. Time T, time taken in seconds, the unit is S. Conventional current and electron flow. Conventional current flow from the positive to the negative end. But electron flow, electronic charges flow from the negative to the positive end. This movement of positive, that means conventional current flow from the positive to the negative end. This movement of positive charges is called conventional current. After the electrons were discovered, it was known that electron flow actually takes place from the negative terminal to the positive terminal of the battery. This movement is known as electron flow. So positive charge, conventional current flow from the positive to the negative end, and electric charge flow from the negative to the positive end. So these are the conventional current and the electron flow. Measurement of electric current. How do we measure current? We make use of an ammeter to measure current. The ammeter should be connected in series to the circuit. So current must flow into positive terminal and leave negative terminal. So electric current is measured using a device called ammeter. The terminals of ammeter are made with positive and negative sign. An ammeter must be connected in series in a circuit. Instruments used to measure similar currents in the milliampere or microampere range are designed as milliammeters or microammeters. So electric current is measured using a device called ammeter. The terminal of ammeter are made with positive and negative sign. Next, potential difference. Electrical charges need energy to push them along a circuit. So water always flows from higher to lower ground. Similarly, an electric charge always flows from a point at higher potential to a point at lower potential, at a point lower potential. An electric current can flow only when there is a potential difference V. So the potential difference, the easiest way to think about what batteries to use a water analogy. Batteries lift charges Q to higher potential. Potential is denoted as V. Already we know that charge is denoted as Q. There is a potential difference V between one end of the battery and the other. So batteries are store potential energy as chemical energy. Unit of potential difference. The SI unit of potential difference is volt. Potential difference between 2 points is measured by using a device called voltmeter. Calculating electric potential difference. Potential difference equal to energy by charge. Potential difference is volt equal to the unit is potential difference unit is volt equal to energy is joule by charge is coulomb. So V equal to E by Q. So volt equal to energy by charge, joule by coulomb. So name potential difference, the unit is volt, symbol is V. Energy, name of is energy, energy unit is joule and symbol is E. Charge, unit of charge is coulomb and symbol is Q. So potential difference can measure using the device voltmeter. Now we will see electrical conductivity and resistivity. What is resistance? An electrical component resists or hit the flow of electric charges when it is connected in a circuit. In a circuit component, the resistance to the flow of charge is similar to how a narrow channel resists the flow of water. So the resistance of a component is the ratio of the potential difference across it to the current flowing through it, R equal to V by I. R is the resistance, V is the volt and I is current. So SI unit of resistance is ohm. Next, electrical conductivity. Electrical conductivity or specific conduction is the measure of material ability to conduct a electric current. So it's commonly represented by the Greek letter sigma. So SI unit of electrical conductivity is sigma or meter. Sigmas by meter. Next, electrical resistivity. Electrical resistivity, also known as specific electrical resistance or volume resistivity, is a fundamental property of material that quantifies how strongly that material opposes the flow of electric current. So the electrical resistivity of unit is ohm per meter. Analogy of electric current with water flow. The pipe is like the wire in the electric circuit. Consider the pipe is like the wire in the electric circuit and the pump is like the battery. We consider pipe like the wire and pump is like the battery. The pressure generated by the pump drives water through the pipe. Then the pressure is like the voltage generated by the battery which divides electrons through the electric circuit. So suppose there are some dust and rust that plug up the pipe and slow the flow of water, creating a pressure difference from one end to the other end of the pipe. So in similar way, the resistance in the electric circuit resists the flow of electrons and creates the voltage drop from one end to the other. So energy loss is on the form of heat across the resistor. Sources of electric current. These are the sources of electric current: batteries, dynamo or generator and other sources. First, batteries convert chemical to electrical energy. Batteries are convert chemical energy to electrical energy. Next, dynamo or generator. Dynamo or generator converts mechanical energy to electrical energy. And other sources are solar, that means solar sunlight, atomic energy, solar energy, atomic energy is nuclear energy, and wind energy and thermal energy. These are the sources of electric current. Next, types of cell. Already you studied about cell. There are two types of cells, primary cell and secondary cell. The primary cell is the dry cell commonly used in torches is an example of a primary cell. It cannot be recharged after use. This is called primary cell. A primary cell is a battery that is designed to be used once and discarded, and not recharged with electricity and reused like a secondary cell in general. So this is the primary cell. We can use once only. Next, secondary cell. Secondary cells are used in automobiles and generators. The chemical reaction in them can be received, hence they can be recharged. So secondary cells we can use many times. So secondary cell is a type of electrical battery which can be charged, discharged into a load and recharged many times. So primary cells we can use only one time, and secondary cell we can use many times. Primary cells are dry cell and secondary cells are lithium cylindrical cells, button cells, alkaline cells and automobile battery. These are secondary cells. And the difference between primary cell and secondary cells are, primary cell, the chemical reaction inside the primary cell is irreversible, but the secondary cell, the chemical reaction inside the secondary cell is reversible. So chemical reactions irreversible in primary cell and chemical reaction reversible in secondary cell. It can be, primary cell cannot be recharged, but secondary cell can be recharged. And examples of secondary cells are lead accumulator, Edison accumulator, and nickel ion accumulator. That is primary cell. It is used to operate devices such as secondary cells, mobile phones, cameras, computers. And example, simple primary cells example, simple voltaic cell, Daniell cell. And examples of secondary cells are lead accumulator, Edison accumulator, etc. In this class we will see primary cell only. Next class we will see about secondary cell. Primary cell, that means simple dry cell. The diagram is simple dry cell. A dry cell is a type of chemical cell commonly used the common form batteries for many electrical appliances. It is a conventional source of electricity available in portable and compact form. And it was developed in 1887 by Eisakyo of Japan. Dry cells are normally used in small devices such as remote control for TV, torch, camera and toys. So a dry cell is a portable from a Lagrange cell. It consists of zinc vessel which acts as a negative electrode and anode. The vessel consists a most paste of sawdust saturated with a solution of ammonium chloride and zinc chloride. In dry cell, anode is a zinc inner case and cathode is a graphite rod. So the chemical is paste of manganese dioxide and carbon and NaHCl. This is the structure of primary cell, simply dry cell. Thank you, children. We'll meet the next